What's up, you freaking geniuses? So in this video, I'm going to teach you how to write recursive and explicit rules and equations. So I'm going to teach you a ton of stuff, all right? So I'm going to show you how to use the rules to find the first few terms in a sequence. I'm also going to show you how to, when you're given just a sequence, how to write a rule for it. And I'm also going to show you how to write an explicit rule for a recursive rule and vice versa, how to write a recursive rule for an explicit rule, right? So that probably sounds like complete gibberish right now, but I promise you it's going to make sense by the time we're done here. So there's basically 4 different little formulas that you're going to have to know, all right? So first of all, let's start with recursive over here, all right? So there's 2 recursive formulas, and you're always going to be able to tell that they are recursive because they're always going to give you the very first term of the sequence, okay? So that's why here it's saying a sub 1 and then comma, right? And then it gives us a little formula, right? And then same thing over here with this other formula, right? It gives us the first term and then it gives us the little formula, okay? Now, these 2 formulas are kind of similar. So this one up here says a sub n is equal to a sub n minus 1 plus d. And then this one down here just says a sub n is equal to r times a sub n minus 1, right? So you can see that they both start with a sub n. They're all going to start with a sub n, these also over here. And then over here we have a sub n minus 1, right? Here we have a sub n minus 1. The only difference is this one has this plus d part, and then down here we have this times r part, right? So when do you use each one? Well, with this one up here, you can see that we have a plus d, right? So we're just adding or subtracting potentially just a number, okay? So when you have a sequence where the difference to get from one number to the next is just adding or subtracting the same number over and over again, you use this first one, all right? And this is called an arithmetic sequence. Okay, so as you can see, I have a little sequence right here for just a quick example. So to get from one number to the next, right, how do you get from 1 to 6? You add 5, right? How do you get from 6 to 11? Well, again, you just add 5, right? 11 to 16, 16 to 21, right? And so on, right? We just keep adding 5, right? So this number right here that we keep adding over and over and over to get to the next number, this is called your common difference, all right? And that's the number you would plug in right here. So for example, for this example anyways, d, right, this d up here would be equal to 5, right? Because 5 is what we keep using. Okay, and then on the other hand, we have this one over here, which is for a geometric sequence. Okay, so then this r right here, this is just for the number that you keep multiplying over and over again to get to the next number, right? So if you look at this sequence over here, how do you get from 2 to 4? Well, you're doubling it, right? So you're multiplying by 2, right? How do you get from 4 to 8? You're doubling it again, right? So you're still multiplying by 2, right? 8 to 16, 16 to 32, right? Still the same thing. We're just multiplying by 2 over and over again, okay? So this number that you keep multiplying by over and over, this is called your common ratio, okay? So then in this example right here, this r right here, right, the r would be equal to 2. Okay, and now for the explicit formulas, all right? So these are very similar. Nothing really changes. The variables just move around a little bit, okay? So this first formula, a sub n is equal to a sub 1 plus, and then in parentheses, n minus 1 times d, okay? And then this other one right here is just a sub n is equal to a sub 1 times r raised to the n minus 1, okay? So as you can see here, again, we're adding on this top one, right? And then down here, we're multiplying, okay? So again, this first formula right here, you would use for an arithmetic sequence, right? So you would use this formula for this type of sequence down here on the left, right? And then this other one, as you can see, we're multiplying, right? So you would use this formula for this geometric type of sequence. All right, here's the first example. So it says write the first 3 terms of each sequence. Okay, so as you can see, we have some recursive rules here, right? And we know they're recursive because it gives us the first term right here and also here, okay? So they're both recursive, and it's just saying that we need to find the first 3 terms, right? So the first one that already gives us, thankfully, so a of 1 is equal to 2, a of 2 is equal to what? Well, let's use this little formula that it gives us. So it says a of n is equal to a of n minus 1 plus 3, okay? So depending on what term you want to look for, so we're looking for the second one, that's where we're going to plug in for our n's right here, okay? So we're going to say a of 2 is equal to a of 2 minus 1 plus 3. All right, a of 2 is equal to a of, or sub 2 minus 1 plus 3, okay? Now this right here, 2 minus 1, that's just equal to 1. So really this is a of 1, right? And we know what a of 1 is equal to. It's just equal to 2, right? So then this is going to be equal to 2 plus 3, and that's equal to 5. Okay, so a of 2 is equal to 5. Now let's find a of 3, okay? Well, again, just plugging it into the formula that it gives us, we're going to have a sub 3 minus 1, right, plus 3, okay? Now 3 minus 1, that's equal to 2, so here we really have a sub 2. And a sub 2, we just found, right, is 5. So here we really have 5 plus 3, and that's equal to 8. Okay, and it doesn't ask for it, but we could also just keep finding more, because you might notice the pattern already, right? We started with 2, then we went to 5, then 8, right? So we're just adding 3 each time. So a sub 4 would be 11, a sub 5 would be 14, right? And etc. Okay, and since we are just adding over and over again, right? We're just adding 3, that means this is an arithmetic sequence, right? Okay, so now let's go to this next example. So here we have a of 1 is equal to 80, and then the little formula that it gives us is a sub n is equal to negative 1/2 times a sub n minus 1. Okay, so again, we're just looking for the first 3 terms, and it gives us the first one. Nice. So a of 1 is equal to 80. Okay, then to find a sub 2, I'm just, again, going to use this little one that it gives us right here. And also, just to point it out right now, here we're multiplying, right? We have negative 1/2 times a sub n minus 1. So we should expect to have a geometric sequence down here, right? Since we're multiplying. All right, so a sub 2, again, we're just going to plug in 2's for the ends right here. So there and there. So we're going to say a sub 2 is equal to negative 1/2 times a sub n minus 1, right? A sub 2 minus 1. Now, 2 minus 1, that's equal to 1. So here we really have a sub 1, right? So here we really have negative 1/2 times a sub 1, right? Negative 1/2 times a sub 1, but we know what a sub 1 is, right? It's just 80. Okay, so half of 80, that's equal to 40. So here we have a negative times a positive, so that's negative 40, right? So that's a sub 2. Now a sub 3, same thing, just using this one right here, right? So we're going to plug in a 3 now. So we're going to say a sub 3 is equal to, negative 1/2 times a sub 3 minus 1. And 3 minus 1, that's equal to 2, right? So we just have a sub 2 right here. And a sub 2, we just found, right? It's equal to negative 40. So here we really have negative 1/2 times negative 40. And that's equal to positive 20. Okay, now we can, same thing, find a 4, a 5 if we wanted to. Now what's the pattern here? Well, you can see that it keeps getting cut in half, right? So here it goes from 80 to 40 to 20. So the next one you would expect to be 10 and 5, right? But the other thing is the sign is also flipping, okay? So here it's positive, here it's negative, here it's positive. So then here it would be negative also. So we would have negative 10. And then here it would be positive, right? So it'd be positive 5. And then it would just keep flipping like that. All right, so this one's basically going to be the opposite of the last one. So this one says write a recursive rule. All right, so we basically start with a sequence and then we just have to write a rule for it. All right, so let's start with this one right here. So the first thing we have to do, since we already know it's recursive, right? We just have to figure out if this is an arithmetic or geometric sequence, right? Are we adding or are we multiplying? Well, to get from negative 30 to negative 18, well, one thing that might stand out is that for each sequence add 12, right? And then to get from negative 18 to negative 6, looks like you add 12 again, right? So it looks like we're just adding 12, right, over and over, okay? So this is an arithmetic sequence. Okay, so the rule, remember, we always include the first term, so we're going to say a sub 1, comma, and then the recursive for when you're adding, right, is, again, a sub n is equal to a sub n minus 1 plus d. Okay, now the only 2 things that we have to fill out to complete our rule is the a sub 1 and the d. Okay, so a sub 1 over here would just be the very first term right here, right? So a sub 1 in this case is equal to negative 30. Rule. And then d is just the number, or the difference, right? The common difference, or the number that you just keep adding or subtracting over and over again. So here you can see it's just 12, right? So here d is equal to 12. Okay, so let's write this out. So we're going to say a sub 1 is equal to negative 30, comma, and then we're going to say a sub n is equal to a sub n minus 1 plus d, or plus 12, right? So that would be our recursive rule for this sequence. All right, now let's go to this one over here. So the sequence that it gives us is 5, negative 20, 80, negative 320, etc., right? So here, well, one thing that kind of stands out is it goes positive, negative, right? Whenever you see that, you're always going to be multiplying by a number, okay? And it's always going to be a negative number, okay? So to get from 5 to 20, we're going to multiply, right, by a negative number, and here it's going to be negative 4, okay? So then same thing over here. To get from negative 20 to 80, we're going to multiply by negative 4, right? Same thing right there. Just multiplying by negative 4, okay? So the number that we keep multiplying by over and over again is negative 4, right? So remember the recursive formula for when you're multiplying is a sub n is equal to r times a sub n minus 1, okay? Now r, again, is just the number that you keep multiplying by over and over, okay? So here r is going to be equal to negative 4. Okay, and remember this is a recursive formula, so we have to include the very first term. like that, okay? So let's fill in some stuff. So the only things we're gonna have to fill in here are the first term, a sub 1, and the common ratio r. Okay, so the first term here is 5, right? So we're gonna say a sub 1 is equal to 5. And we're gonna say a sub n is equal to the common ratio r, which is -4, times a sub n minus 1. All right, so this is our recursive rule for this one right here. All right, so here it says write an explicit rule for each recursive rule, okay? So these are recursive rules, right? It gives us the first terms. So we're going to convert them to explicit rules. Okay, so remember, there's two explicit rules, right? One for when you're adding or subtracting, and the other one for when you're multiplying, right? So for this first one right here, you can see that we have a sub n minus 1 minus 10, right? So here we're adding or subtracting, right? So this is an arithmetic rule. So we're going to use the explicit rule for when you're adding or subtracting, which again is just a sub n is equal to a sub 1 plus n minus 1 times d, okay? And then over here, we have a sub n is equal to negative 0.5 times a sub n minus 1. So we're multiplying over here, right? So the explicit rule for when you're multiplying is a sub n is equal to a sub 1 times r raised to the n minus 1. Okay, so we're going to convert, and I forgot to include this a sub n over here, so I just stuck that in real quick. So this one is a sub n is equal to, right, a sub n minus 1 minus 10. All right, so we're going to convert this to an explicit rule. All right, and it's actually not that difficult. We just have to use the information here to fill in a couple of the pieces here. So we know the first term, right, a sub 1, so we're going to plug that in right there for the first term. And then we also know the plus or minus d part, right? So what's d in this case? Well, it'd be negative 10. Okay, so that's what we're going to plug in for d right there. So then we're just going to say a sub n is equal to the first term 25 plus n minus 1 times negative 10. All right, and now we can just simplify some things here. So we're going to say a sub n is equal to 25, and then we're just going to distribute this negative 10 into these parentheses. So negative 10 times n is negative 10n, right? And then negative 10 times negative 1 is positive 10, right? So plus 10, okay? Now just combining like terms, right? 25 plus 10 is equal to 35. So we're going to say a sub n is equal to negative 10n plus 35, all right? So then this would be your final rule right there. Okay, now let's go to this one up here. So again, we're just going to convert this formula, right? This recursive rule to this explicit rule. And again, we're just plugging in a couple things that we know. So again, we know the first term, right, 19.6, and then we also know the ratio r, negative 0.5. Okay, so we're going to plug that in for the first term and for the r right there. So we're going to have a sub n is equal to 19.6 times r, so negative 0.5 raised to the n minus 1. Okay, now here there's nothing we can really simplify, so this would be your final answer right there. All right, so these are basically just going to be the opposite of what we just did. So this one says, write a recursive rule for each explicit rule, right? So we're just going to convert these explicit rules right here to recursive. So with this first one right here, we have a sub n is equal to negative 4n plus 2. So here, again, we're adding, so that means we're going to convert this to the recursive rule that deals with adding or subtracting, right? So again, that's, I'm going to move it down here a little bit. A sub 1, comma, and then we're going to have a sub n is equal to a sub n minus 1 plus d. Now, as you can tell, this explicit rule doesn't give us the very first term, right? Because we're going to have to find the very first term of the sequence. So since it doesn't give it to us, we actually have to find that first, all right? So to do that, all you have to do is plug in a 1 for the n's right here. Okay, so we're going to say that a sub 1 is equal to negative 4 times 1 plus 2, all right? So then here, a sub 1 is equal to negative 4 plus 2, and that's equal to negative 2. All right, so a sub 1 is equal to negative 2, right? So that's what we're going to plug in for our a sub 1. And then the last thing we have to figure out is this d part right here, so plus d, okay? And that number comes from whatever number's attached to the n over here in the explicit rule, so negative 4, okay? So then here, d is going to be equal to negative 4. Okay, so if we write out our rule, we're going to have a sub 1 is equal to the first term, which again we found to be negative 2, right, comma, a sub n is equal to a sub n minus 1 minus 4, right, negative 4, okay? So that'd be the rule right there. And then lastly, we have this one right here, right? So a sub n is equal to negative 81 times 2/3 raised to the n minus 1. So obviously we're multiplying right here, right? So we're going to use the recursive rule for multiplication, which again is a sub n is equal to r times a sub n minus 1. Okay, and just like in the last one, remember we have to include the first term. Okay, and to do that, it's actually kind of easier with the multiplication one. So remember the explicit rule for multiplication, right? The base rule is a sub n is equal to a sub 1 times r raised to the n minus 1. Okay, so then we could just kind of match stuff up here, right? So you can see that the very first term, a sub 1, is just this number right here in this spot, right? So we know a sub 1 is equal to negative 81. Okay, and we can also identify the r, the common ratio, right? So r is equal to whatever number's right here in these parentheses, which is 2/3. Okay, so then we know that r is equal to 2/3. Okay, so those are the only two numbers we need to plug in right here. So we're going to say that a sub 1 is equal to negative 81, comma, and then we're going to say a sub n is equal to r, which again is 2/3, times, I'll put that in parentheses, times a sub n minus 1. Boom!
So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.